All right, welcome back everybody. Let's talk about distance in one dimension. So this is called the ruler postulate. It's in 1.2 in your textbook. And all we're doing is we're trying to find the distance between A and B. Remember that we talked about absolute value. These are the absolute value signs, and they indicate that once we're done doing the things on the inside of the absolute value sign, it's always going to be positive because distance is always positive, right? So it really doesn't matter which one is x1 and which one is x2, but it does matter that you recognize that this is x subscript 2, meaning this is the second x, and this is x subscript 1, meaning this is the first x. A could have just as easily been x sub 2 because it doesn't matter which order this is in because of the absolute value signs. Okay, so moving on. Let's say I have, like I'm going somewhere and I start at mile marker 10 and I end up at mile marker 16. Well, how far did I go? Well, that's easy, right? We're just going to subtract the two. So we've got 16 minus 10, but we could have just as easily done 10 minus 16. Let's see, what's 16 minus 10? Well, that's 6. What's the absolute value of 6? Well, it's still a positive 6. Now, if we had done it the other way around, if we had done 10 minus 16, that would have been a negative 6, but the absolute value of negative 6 is still a positive 6. So the distance in one dimension for AB is just 6. Okay, so this is instructions. Feel free to pause them whenever you need to. Right, so this is just showing the other way to do it. So 10 minus 16 would have been a negative 6, and it still would have ended up being a positive 6. Okay, so let's refresh the segment addition postulate as well. We're shifting gears here to the things that we were talking about earlier. A, B, and BC, these two segments is still the same as AC. Adding the parts equals the whole, right? So 23 plus 35 DE plus EF is still going to be DF. Now, what's really important here is that you actually write down DE plus EF. That's really important, equals DF. Now, what's even better is if you actually use the line segment line over all of these line segments, because that way we know exactly what you're talking about. Now, after we've written this down, we're going to substitute in our numbers. We'll substitute in our knowns so that we know what our unknown is. We know that DF is our unknown, so 23 plus 35, that's going to be 58. And this is why it's really important. So we're going to write FG plus GH, because those are the parts. Add the parts to get the whole. FG plus GH equals FH. Let's write it down. FG plus GH equals FH. We know that FG is 12. We don't know what GH is, so let's leave it as GH. Or you could replace it with a variable. Equals 36. So 36 is the whole. So now we have a one-step algebra problem, huh? So in order to solve for GH, we need to subtract 12 from both sides. And that's 24. So GH is finally by itself after we subtract the 12, and we're ending up with 24. Now remember, they have to be collinear for these segments to add up together. So like SR plus ST is not the same as RT. All right, that's it for right now. The thing that I really want you to remember is how to do this one-dimensional distance stuff. You've got the other YouTube video if you want to check on the other stuff. Feel free to rewind, rewatch, and ask questions. Thank you, everybody.